My screen here. I hope you can see me. I hope you can see the screen. I hope you can hear me well. Let me know otherwise. My name is Lars Albertsson. I run a small data engineering startup named Skling, and I will tell you what we do at the end of the presentation. So shifting left, where is left? Well, left is up. It's up the water flow chain. Where does water flow come from? There was this fellow named Winston Royce in 1970. He wrote a paper named Managing the Development of Large Software Systems. And he observed that this is how systems seems to be built. There are these discrete phases that do not overlap, and you do the requirements before the analysis, before the design, before the coding, before the testing, before you put things into operation. He didn't call it waterfall, but after people read this paper, they say, oh, yes, this is how we work. We now have a methodology. Let's call it waterfall. So this dominated for a long time. And shifting left is all about mixing up these phases, shifting things from the right here, from operations up to left, and also from coding up left towards requirements. So let us look at how these things happen and why we want to do this. Well, if you have it work in discrete steps, it turns out that you get into this trade-off where if you work faster in one step, things get worse in another step. If you crank out too much features, the quality gets worse or the security gets worse or something. So there has been this assumption that there is a trade-off between speed and other properties of your program. So if you go into a large company, or it doesn't have to be large, but that has this sort of enterprise culture where people are in different teams doing different things. You often observe this situation that you try to achieve something, and then you meet people and you talk to them, and after a while you sort of want to say, is your job task to make me fail, like to prevent me from succeeding? And if you say that, they will actually say, well, it seems like your job task is to prevent me from succeeding, right? One wants to crank out features, one wants to make sure that the security is good, or that the risk is managed, or that we are compliant, whatever. So we have this, by virtue of our organization, we end up with these trade-offs where things sort of become a zero-sum game. So if in order for one team of one person to succeed, life becomes more difficult for other people. And what I've seen happen is that the people find ways around these constructs. So for example, I've seen or companies with security is very strict and follows strict procedures and so forth. And people go to security meetings and they say, yes, this is fine. And then they go back and then they unplug from the corporate network and plug in their mobile phone to download software from the internet and so forth. So the result is that security doesn't really get better. So what happened after the waterfall was that it reigned for decades as the predominant technology. But as the 90s came and the dot-com crash, it became apparent that things were not really working well. We had these huge IT projects that didn't work super well, and people started questioning the way things worked, and started moving away from the waterfall model and realized that maybe it wasn't so perfect after all. So let us look at a couple of these shifts happened and see the ones that have already happened, see if we can learn from them. So one of the things that sort of muddled up first was that we started to combine design and programming and quality assurance. This became one of the names that it became known as was extreme programming. The book came out, I believe it was written by Kent Beck and came out in 99, I think. And it didn't start at that point, but gave to name. I think the first evidence that I've seen of like test-driven development is the OAK open source program, and they worked in the test-driven way back in 1983. But this, as we now know, proved to be a good thing to make people work together instead of coding things, throw them over the wall to a bunch of QA people who swore about the bad quality of the developers and then made bug reports, threw them back over the wall to the developers who swore at the nitpicking made by QA people who didn't seem to know what was important and so forth. Instead of that, people worked together in the same team, sitting next to each other and combine the different competencies. And we now know that this worked out fairly well. So great, if we have a shift that has worked out well, how are you able to make that shift? Maybe it's something we can learn from here. And this is a way to change the way people work. And that is very difficult to do because it's a cultural shift. And the most successful example that I've seen of a culture shift is the test certified program that came out at Google. I think it was formulated 05, 06 sometimes. I joined Google in 2007, and this was a tremendous help in raising the software developer test competence in the company. What it gave was a maturity model so that you could see sort of how mature you were as a team in doing developer testing. But more importantly, it gave a ladder. It gave you definitions of what things should we do next in order to improve. And that ladder proved to make a huge difference. Teams put it in their OKRs to say, next quarter, we're going to rise to level 2, and then 3, and then 4, and then 5, and so forth. And this really made a shift throughout the company. Eventually, the culture was embedded in the company, and the ladder wasn't needed anymore. Let's look at another shift, which is the shift of combining coding and program design with requirements. So instead of making all the requirements up front, as in the traditional waterfall model, let's do some preliminary requirements, then implement them, see what happens, and then refine the requirements. Today, this is known as Agile. We all know that this proved out to be a good and successful transform that has helped us tremendously. There's no Agile certified ladder that I'm aware of. Instead, there are things that you can look at, models that people have created. Either created as a sort of large framework with perhaps the underlying assumption that there is money and consultancy to be made, or made just as sharing with the world for reasons that we can speculate in, but not to make money, but rather say, here's what we did. And you can look at us and draw conclusions and maybe take some bits and pieces and so forth, and learn from that and choose your own journey. I follow on social media lots of sort of agile gurus and coaches, and it's very popular to crank down on following SAFe or the Spotify model and so forth. But I think that is somewhat arrogant. It's like it's like Mozart saying that you don't need notes. Like, I mean, if you're a genius, you don't need any notes, or if you're a master chef, to say that you don't need recipes, right? For geniuses, no, they don't need the recipes. But for us ordinary people, having a model to look at is very, very useful. So I wouldn't underestimate the power of these models. And it doesn't matter if they fit well or not. There is great value in having some externally defined model, because it doesn't get hooked up in politics as easy as if you try to invent everything internally on your own. So the next shift that I would like to look at is DevOps, which we also know by now is a good idea. And that is a shift where we take design, coding, testing, and operations and bundle them up and do them within the same team, work together with different competences, and do it as one and iterate quickly. Now, what's interesting with DevOps is that it was recently proven that this is actually beneficial for all aspects. There is no trade-off. It's not a zero-sum game. So Nicole Forsgren et al., they measured how organizations adopted DevOps and how they behave. And they concluded that there isn't a trade-off between speed and stability, for example. Because the teams that have adopted these practices, they move faster, they deploy more often, but their systems are also more reliable. And this came as a great blessing to me when I was working as a consultant, because you used to meet these arguments as well. We're a bank, so we can't just deploy at any time or deploy 10 times a day. Well, it turns out that yes, you can, and it actually would improve the reliability of your systems. And I believe that all of the shifts that we will see, the past, the present, and the future shifts, will all turn out to be a case of no trade-offs. By modeling up this waterfall process that is still fairly common, we would gain on all sides. One thing that I conclude from the successful left shifts from the past is that the focus should not be tooling, infrastructure, technical processes, but the focus, the things that make them succeed, is that you work with people. You change the way how people work together and collaborate. And you work with changing the way things are coupled. You decouple some things, you couple other things together. I think that has been a theme in all of the shifts that were presented so far. And another observation is that some of the technologies that have been really, really disruptive in IT have been disruptive in part because they change the way we collaborate, not so much because of the features they bring, because they change how we collaborate. For example, the relational databases, they gave us a new way to collaborating with data, and they also put a bridge between the IT, the technical world, and the analyst world, because you could work with them in a sort of human-like language, SQL. Version control enabled us to work together, more than just a few people, on the same project efficiently. And the open source movement, in particular GNU and Linux, gave us an innovation platform where we together, multiple organizations could do innovation together. That hadn't been possible without open source. And in order to collaborate on open source, we got things like Git and GitHub distributed version control, so that we could collaborate together without first establishing a bond of trust. So people that do not trust each other can nevertheless collaborate. Likewise, we see with containers has given us a new way of collaborating, because it's decoupled us from IT. We can now create things and deploy things without synchronizing with the IT department to get new machines and new infrastructure and so forth. And the cloud takes that even further, because whereas containers, we need to have machines already running that we can put our containers in. Cloud enables us to build infrastructure without first synchronizing with IT. Hadoop. Why is Hadoop here? I will explain in a moment. First, let's go to the big data shift. Big data is often viewed as technology, but it's much more about collaboration and the way people work. Big data came along, invented by Google, and was spread to the world after Hadoop. And it gave us a way to measure programs, all of the integrated details of programs out in the wild, because it was suddenly cheap enough to store all of the measurements. So we didn't need to design a perfect program. We could sort of throw something out there, measure how it behaved, and then loop back and then do redesign based on measurements of its behavior. So Hadoop, when it came out, it was very, very primitive. It could only do a few things. It scaled down in terms of features and functionality in order to be able to scale in quantity. It could store files. You could do batch processing with MapReduce, and you had HBase, which was not a fully relational database, but like a single dimension database where you could have indexes in single dimension. These are very, very primitive features. And because of these primitive features, you need to adopt a few new ways of working, or very primitive ways of working. Since you can't change any data in the files, you need to have immutable data. And since you can only work like transform things you can only process things by transforming the immutable data to new immutable data sets. You need to work in pipelines that transforms one step after another. It's similar to functional programming, where you don't mutate things, instead you transform them. And because the Hadoop clusters are really expensive to operate, you often have this single, like, homogeneous data lake where all people work the same way, and you have coordinated workflows. These properties of the way that people work came out of necessity for the limitations of Hadoop. But they turned out to be a gift in disguise, because what this led to was that data was democratized within the organization. If you have a lake where all of the data is available and it's immutable, you can easily share the data, right? Because since it's not mutating, you won't destroy the data features for everybody else. You can just freely read from them and innovate and have bottom-up innovation. And because things are functional and immutable, it turns out that you can throw new things out with very little risk. And if something goes wrong, you just rerun the transformation. So you can operate with very, very small operations, and therefore throw out your innovations much more quickly. These things are the real actual value of the big data transform. And this is quite poorly understood. And the early adopters achieve this value, but the late adopters of Hadoop and similar technologies, they did not achieve the value because they try to preserve their own workflows. And and when you go to, and the enterprises that adopted Hadoop and big data workflows, they went to the Hadoop vendors and say, we'd like to keep our workflows. Can you please give us a way to mutate the data? Can you please give us ability to write SQL and transactions and so forth? Because we'd like to keep our workflows. And they never got the same value out of it. So if we look at the current shifts that are going on instead, they are pretty much focused on shifting operations up to various, combined with various different earlier steps. So when big data and the data pipelines became part of important production pipelines, the need to build data pipelines with quality and with reliability became more apparent. And the answer here is what we call DataOps, and bringing the operations up into data engineering. It used to be the case that and they, just like with software development, you throw things over the wall. You would code your data transformations and throw things over the wall, and then they would perhaps work in operations or not. If you adopt DataOps, the DataOps way of working, the things that you do in operations and the quality measurements on the real life, on the production running systems, are as important as the earlier work. So going back to the this way of working with DataOps is what the enterprises and the late adopters of Hadoop have not yet gotten into. We made a DataOps transformation in 2013 at Spotify. It didn't yet have a name, but it really changed the way we worked, and we enabled the teams across the organization to get benefit from data. Based on the principles that I mentioned earlier. But that is a transform that most traditional companies yet have to do, and most companies have also not realized that this is something that they need to do, because what we see is very much is that the big data adoption becomes using big data technologies and then combining them with traditional workflows. And unfortunately, we see a lot of from a big data vendors, a lot of help in doing this. Like you don't need, for example, there are technologies coming out that will support mutability in data lakes and so forth. We've seen this also happen to some degree with DevOps, where the DevOps transform in a traditional environment becomes very much adopting new technology, whereas still keeping the old ways of working, whereas it should really be the other way around. You could do it with old technology, but it's new ways of working that will actually make a difference for you. So how does one succeed in these shifts, whether it's DataOps or DevOps and so forth? Well, what I've seen work is when you mix people together. If people are in different teams and they have different goals, then it's very difficult to change the way that people work. Whereas if you pitch them together and have common goals and common definition of success, and give them common incentives, and so that one team is not the gateway for another team, then you have a chance of succeeding. I've also concluded that it's important to have common tools and environments. If you have one team working in one set of tools with one language, and then they throw things over the wall and then you have to translate things to another language, or they don't work well together and so forth, then it's much more difficult to align. There's another principle that I see going through all of these shifts, and that's the principle of stop working with things as a craft, where you have a piece, something valuable, and you by hand sort of improve it to working with things as processes, instead of the engineers working on the thing itself, like improving your fancy car or building furniture, you take the engineers to work with the process and improve the process. So, and then the machinery builds the actual things. The first time that I encountered this in the IT world was when I was a student or worked at IBM back in '94. And we had this, I worked with OS/2 machines, and I was used to working with Windows on my home PC. And working with Windows machines is typically a craft. Like you work with a machine until it sort of gets better, and then hopefully it's good enough. But you kind of replicate that easily on another machine. In OS/2, it was the other way around. You installed machines by going with a floppy and booting the machine from the floppy, and then it would contact the installation server, and it would figure out the process of reinstalling this machine and probing the hardware and downloading everything it needed from the server. So it was like building containers, but back in '94, but the whole machine was like built in place. And so people weren't used to this, so sometimes they put local things on the machines, and then somebody reinstalled it and they were overrun. But this was tremendously more efficient than working with as a craft. And it's a way of like shifting from craft to process. If you look in IT, this is a theme of shifts that have gone. We no longer have, we try to go away from physical infrastructure to working with infrastructure as code. We try to not install applications on our machines by using SSH and copying files, but we use containers instead, and so on and so forth. So this is a central theme, and it's perhaps more obvious, even more obvious in data processing, where we have moved from the mutable databases, where we will sort of work with the contents of the database to working with data factories and data pipelines, where we transform the data as it flows through the system. So, and this is also a theme for another of the shifts going on, which is security, where it used to be the case that we looked at the system and see if it was secure or not, and then we made some changes, and then we took another look at the system, and then we had people acting like gateways to ensure that the system is secure. We see a shift here of security moving way up into the coding phase and design phases and so forth. And the theme of turning things into from crafts into processes comes back, because rather than validating that the systems are secure, we strive to validate changes to the system, so that we start out with a secure system and then validate each chain by looking at the PRs, looking at the changes and so forth. And the systems will never be secure, perfectly secure, but instead we can make this shift effective by focusing on each little step to ensure that the system is going in the right direction. So if we run vulnerability scans, for example, we will get tons of reports, and some of them may be false, but do we get more reports than yesterday, right? So focus on the delta and make it easy to build secure rather than unsecure. Focus on the process. There are shifts that we have not yet gone through and that will come, and where there is still a trade-off between speed and security, compliance, machine learning. Putting security here because security is still one of these things that where there is on the wrong side of speed, right? Unlike for example quality assurance, where we have realized that if we work with together, we can achieve both better quality and feature speed. So if we quickly look at those, machine learning is a sort of extension of DataOps, where we throw in data science into the mix. And this is more difficult because the data science people or the data science team are used to work with different tools and so we need to integrate the way they work, the way they tools, in a way that it makes them happy but also makes everybody else happy. So you can't put Jupyter notebooks into production. On the other hand, you can't make data scientists work with Java, because then they will leave. So we have to find common ground to make these data science and operations integrate and so forth in order to, this is a prerequisite for doing sustainable machine learning. If today most of the machine learning looks like this, you take some data, you create a model, and then you throw the model out into production. And whereas sustainable machine learning requires a whole set of things all around, right? Where you measure the input data, see if it's good enough, you repair it if it's not, you measure the properties of the model, you actually build multiple models, you measure them to see which one works best into production and so forth. So there's a whole bunch of like data engineering that is required to do sustainable models. So therefore, you cannot have sustainable machine learning unless you also do this sort of the ML ops and shift everything together, shift left. Compliance is similar to security in the sense that it's still on the wrong side of speed. If it's a gateway rather than anything else, and the solutions are similar to security. Like you focus instead on not on the compliance of the system, but on compliance of all of the changes. Before Spotify went into IPO, we did a whole bunch of compliance work on the financial calculations, and this turns out we got it to work really well. It turns out not to be a trade-off with speed at all, so we could continue with our continuous deployment and data ops ways of working and so forth, and still be compliant. So how do you succeed with the shift? It takes a really long time. I've mentioned some examples of things that you can do to help you. You can look at others, you can have ladders and so forth, but the themes on ignoring the technology, working with people and how people collaborate in teams, and going from craft to process and focus on the changes are central. But I believe that this is, I'm not patient. This is still too slow a process for many companies. So I believe that we should, if we collaborate across cultures, across companies, we can move much faster. So if we look at data as one example, the companies that have achieved data maturity and that get lots of value from data run in circles around the companies that haven't in terms of getting value from the data. So if you're in a company that haven't yet achieved data maturity, you can sort of try to adopt to the data ops and get the big data technology in there and the ways of working and so forth. This takes a long time, and there are plenty of examples of failures here. Or you can say, well, scratch those, I'll make a startup and I'll disrupt some vertical here, because with powers of algorithms and data and the ways of working, we can run in circles around these old behemoths. Now that turns out often to be fairly difficult because the domains are complex. So for example, accounting and legal are domains that are really ripe for disruption. But the domains themselves are so complex that it's difficult to come in with a legal startup and get the trust and so forth. So that is also a very risky business, and that's why we founded Skling. We believe in new ways of collaborating, where we collaborate between us that know the data ops, know the ML ops and so forth, and know the ways of working with the clients who know the domain, and together we form teams to sort of get value from the client's data, but still be two different organizations. And this, we believe, is the fastest way for clients to learn the sort of data ops and ML ops ways of working. So what about Winston Royce? Is he sad now that the waterfall model is gone? No, it turns out that he actually tried to warn us. He looked at the waterfall model and says, this is not efficient at all. We should collapse some of these stages and shift left and do some of the things in iterations and get feedback going instead of having these discrete stages. But somehow people forgot to read that from his paper. So, and it was only until the 90s that things started to change. So, and he passed away in 95. So he never got to see the sort of the fruits, the real shift starting with extreme programming and agile and so forth, which I find very sad. But I think they would have been happy to see these shifts start going. So what do you leave behind? What is your ghost? This is my Kataga statement. What we do, we have built amazing things, but we have also built things that some of them have a strong negative effect and threaten our democracy and our environment. So the examples on this page is things that I care about. Maybe you don't care about them, but you have tremendous power from working with tech, and you affect the world a lot. So make sure you make an active choice whether to use that power or not. Don't just give it away for somebody else to choose for you. Choose money or choose to have an impact on something, but make an active choice and be very aware of how much power you have, the work that you do, and the choices that you make. Thank you.